Hey everybody, Mr. Piercy here, and what we're going to be looking at right now is the investigation over reflections, one of the four types of transformations that we're studying in geometry. So real quick, the materials list that you see here, the Mira, that's not really something that you need. You definitely need graph paper, and patty paper may be helpful to you when doing the reflection. But what we're going to be looking at here is there's four particular lines that when you reflect an image across it, there is a pattern, a rule that we can generate and use that rule to perform reflections or identify what the rule might have been if you have a pre-image with an image that was reflected. Now you do need some graph paper as you've done this, and let me emphasize, this is a reflection video. You should have done the investigation before you watch this lesson or before you watch this video, because this is just to kind of verify your thoughts, verify that you have your rules down correctly, and not meant to be used as the instructional piece itself. The investigation is the main piece of instruction. Now, you have a quadrilateral that you plot the points, and when you reflect it across the x-axis, you generate a new set of points, which is the middle column, and you notice that we get this thing that we can identify by saying, well, from the original figure to the new figure, by reflecting across the x-axis, the x-coordinates don't change, but the y-coordinates do, which kind of makes sense, because if I reflect something across the x-axis, if I have, something like this, let's just say I have this point here. If I reflect something across the x-axis, let's say this is at 3 and 3. Well, it's going to go down 3 spaces to get to the line of reflection, then it's going to go another 3 spaces. So all we're doing is a vertical motion, and if we're only moving up and down, it makes sense that the y-coordinates change because the y-coordinates are our vertical motions. And it's the same thing with the x-coordinates. If I take that same 3, 3 point here, and I reflect it 3 spaces to get to my line of reflection, and I go 3 spaces past it, we're not moving up or down. However, we are moving horizontally, so the x-coordinates will change because the x-coordinates represent my horizontal motion. So pay attention to the rules that we have here and here. Those are the two easy ones when it comes to the reflections. Not that the other ones are necessarily difficult, but those are the easier ones to remember. Now we're looking at the slope of the figures. Okay, well, the slope of the figures originally, oh no.
Morning. Would the following teachers please report to the Career Center?
All right, I had to pause the video there for a second. Sorry for the interruption, but they were making announcements over the intercom. So the slopes of the original figures, two of them are undefined. One of them has a slope of 2/3, one of them has a slope of 1/3. And what we're noticing is that when we do our reflections over the x and y axis respectively, the value of the slope, the absolute value of the slope doesn't change. We still have 1/3 respectively. However, the sign, the direction that the slopes are going changes. Now, a reflection, what we're seeing here, even though it's not necessarily asking you to do the distance formula, here what it's by performing the reflections, we still wind up with a figure that is congruent to the pre-image that we started with. However, the figure itself is going to be in a different orientation, and that's one of the key differences between reflections and what we've seen so far with translations. So here we have a triangle that we're now going to be reflecting across a couple of lines. We're going to reflect it across the line y is equal to x, which is your linear parent function, and you're going to reflect it across the line y is equal to negative x, which is, well, still goes through the origin, but has a slope of -1. Now, what we're seeing when we're looking at the line y is equal to x, what we notice is that all that happens is that the input and output numbers, the x and y numbers, change positions. And if you notice what I'm telling you here, it's not something that we really pay attention to in geometry per se. However, in an algebra course, something that you'll probably do in Algebra 2 or Pre-Cal, when you're talking about inverse functions are reflected across the line, y is equal to x, so their inputs and outputs change, just like what we're seeing here in our table. Now for the reflection across the line, y is equal to negative x, that one is not something that you're going to see, again, really outside of the geometry course, but the line y is equal to x, that is going to be a characteristic of inverse functions that you see in Algebra 2 and Pre-Cal. Now here, again, same thing with the slopes that we saw before, is that the slopes themselves, they're not going to change so much in the fact that we're going to wind up with a figure that is a different shape or that it's bigger. A reflection is an isometry. It produces congruent figures. However, the orientation of the shape will be different, and that's exactly what we're seeing with our table here. The slopes of the figures are different. We're taking the reciprocal of the slopes now as opposed to just changing the signs. So it describes any relationships that you see. Now this is something that we're looking at here. We're just trying to see, well, what are all of the things that we've noticed? So if you need to, take a moment and add whatever additional information that you need to your own investigation, and we'll move on, and you'll hit play whenever you're ready. But I have to stress, you really need to make sure that you can identify these things. At some point in the future, hint, hint, wink, wink, you'll be asked to do this very same thing on your own. And the question is based off of this idea right here from your investigations. So make sure that you can identify all of these things at some point later. Here, what we're looking at, we're doing multiple lines of reflection. And this is something that sometimes students do struggle with when we do it. Because they don't take into account that we're actually reflecting an image twice. So we're taking a pre-image, we're going to perform a reflection, which creates an image. And then we're going to take the image and do another reflection, which creates a second image, which we would when we do our notation, we would start with like our double prime notation, where we put two apostrophes at the end of the figures. And that's what you're seeing in that last column. So we start with A, which is the pre-image. Then we go to A prime, which is the image after I perform the first reflection, and then we go to A double prime after I finish with my last reflection. So double check your coordinates here, make sure you're okay with what we're doing, and again, looking for the patterns that we're seeing at the bottom. The slopes of the figures, well, the slopes of the figures themselves, they'll change based off of whatever the reflections that we noticed before did. So when I take the original figure and reflect it across the x-axis, well, the sign of the slope changes because, well, if before it was positive, now it's negative. If it was negative before, now it's positive. But when I reflect it across the line y is equal to x, it changes much more than it changes the orientation a little bit more, and so the slope changes from whatever it was before to now we have its reciprocal, not its negative reciprocal or opposite reciprocal, just the reciprocal of the value. Now we're going to take the same one and perform the following reflections. We're going to take it and reflect it across the y-axis and then reflect it across the line y is equal to x, and you should see the following coordinates here. Take a moment and double check them on your own papers and see how you do. And finally, take another look at the slopes here. So there we go. And again, compare your values. The slopes overall aren't really changing to the point where the figure itself is different. The fact that the slopes are different is merely indicating that we are changing the orientation of the figure itself. If we actually took the time and did the distance formula of the corresponding sides, we would see that all the triangles would be congruent to each other. So the last one here, reflect the new image across the line y is equal to negative x. So again, we're doing, double reflection, and we should see our points here. Double check, make sure you're okay. And here, our last, I believe this is our last table here, where we're just kind of looking at the slopes. Describe any relationships that you've noticed. So here, the relationships don't really change from what we did before. So the answers that you had, where you described the relationships that you saw previously, they're pretty much the same thing here. But again, pause the video, make sure you compare your answers with mine. If there's something that I have that you do not have, you definitely need to add it to your paper. Now we're going to be actually applying it. These are not exactly problems that you would see on an assignment, but they're like problems that you would see on an assignment. So we're just saying, well, I have these slopes. If I have these slopes and I perform these particular reflections, what would happen to the slope? And so here it's actually starting to make you apply how we're going to be using those rules, those patterns that we see. So here are the slopes respectively. Please make sure you double check your answers. Same thing here, find the slope of the lines. Now pay attention that we're actually doing 2 reflections for each one. So make sure you pay attention to that. And here, this is again kind of an application process where you would be doing maybe you would be given this as a question on a quiz or a homework assignment or a test where you have this point and you perform this reflection, where would it wind up? Or if I tell you this is where the image is, this is where the pre-image is, what kind of reflection or transformation did we do? So here we're reflected across the x-axis. Here B is y is equal to x. Here the y-axis. Part D, if you notice, it has a little star on there telling you that it's doing multiple reflections. So it's going to be reflected across the x-axis and then across the y-axis. And then part E is reflected across the line y is equal to negative x. Now, any other figure can be reflected across a line of some kind. Now, this isn't something that I'm going to ask you to do because of the fact they don't generate any kind of particular pattern. So let's say we have some line. Let's say we have some line. So clearly this is not one of the 4 lines that we did our line of reflections across. What I would do now for something like this is I might have a figure. So let's say we have a triangle. Well, all of the points of reflection, all of the points here that make up this triangle, they would be reflected the same distance across the green line. So however far it is from point A to the green line is how far I would go past it. But what we need to recognize is that the distance between my point and the line of reflection, the shortest distance is going to be a perpendicular line. So I would go the same distance past it, however far that is, and that's where A prime would be. All of the lines of reflection that we're doing, if you go back and you kind of look at how, the image, the points of the pre-image to the points of the image, they're all going to be reflected a lot across a line where if you drew a line from the pre-image to the image point, they would create perpendicular lines with the line of reflection. Now, last thing I want to talk about before we wrap up is the rules that you're going to be generating here for how the coordinates change based off of the type of reflection that you have. It's not going to be something that you will see too much outside of a geometry classroom. The next place where you're really going to be tested on this knowledge will probably be an SAT type exam. So while I don't expect you to necessarily remember all the rules from now to when you have to take your SAT exam, hopefully by going through the process of this, you'll be able to at least be able recreate the rules or recreate how you would perform a reflection at some point if you needed to do it in the future. Now for your test that you'll be taking in this class over this material, don't rely on being able to recreate the rules because there simply won't be enough time to do that. Okay, that's it for this lesson, ladies and gentlemen, talking about reflections. If you have any questions about anything, by all means, let me know what they are. I'll be happy to work with you on any questions that you have. But until next time, guys, thanks for watching and take care.